Unit 5, Topic 4, Frequency Tables and Histograms. This is the beginning of statistics and talking about how to display data and how to keep track of data. I don't know if any of you remember from my introduction, but my background is actually in statistical modeling. I had an emphasis on it in graduate school, but also I did it for work for several years, and I do really love statistics. So hopefully this will be interesting to a lot of you. It's very applicable. It's very straightforward, or hopefully it's straightforward. But if you have any questions, let me know. So let's go ahead and dive in. In some experiments, it is hard to keep track of each data value, especially when there is so much data. Instead of listing each value, we can summarize how many times the data appears, frequency, and then look at the data graphically, histograms. So when a data value occurs a number of times, this is referred to as the frequency of the data value. By taking the frequencies, a table can be constructed. In most cases, there are two columns, one for the data and the other for each frequency. Let's go ahead and take a look at an example. Suppose a group of 20 students were asked how many hours they worked per day. The responses follow. 5, 6, etc., all the way down to 3. I'm not going to read them in detail. Again, this is kind of why these frequency tables, it's cumbersome to look at all those numbers and it's not necessarily useful. So construct a frequency table. So the way I'm going to do it, I'm going to go through and mark up and show you kind of how we would do this. So let's see. First we're looking for all the 2s. So here we have a 2. So we have 1, 2, 3. So there are 3 2s. So the frequency for the value of 2 is 3. Now we're going to look at all the 3s. We have 1, 2, 3, 4, 5. So we have 5 3s. Now the 4s, we have 1, 2, 3, 3 4s. Let's look at our 5s. We have 1, 2, 3, 4, 5, 6. For 6, we have 1, 2, and then for 7, we just have 1. One of the most important things that we need to check is that the sum of these equals 20. So in this case, the total frequency is 20. If your table doesn't sum to the same number, so here we have 20 variables. We have 20 values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we need to check. We have 3 plus 5 is 8, plus 3 is 11, plus 6 is 17, plus 2 is 19, plus 1 is 20. If they don't sum up to the same number of data values you had, there's a mistake somewhere. So it's an easy, very quick check you can do to make sure you did it correctly. Oops. All right. Important, the total number of the frequency should always add up to the given number in the example, like I just mentioned. We already did an example, so that's pretty straightforward. Next, we're going to talk about relative frequencies. The relative frequency is the ratio of the number of times a data value occurs. Relative frequencies are usually listed as decimals with 2 places. They can also be recorded as fractions or percents. Now, just really quick aside, just in the professional world of statistics, you often would not see fractions. It's not something we saw, or percents. Typically, you would see it as decimals. And when you start talking about probability and sample probabilities, this is kind of what you're looking at as a relative frequency. So let's look at an example of the students, how many hours they work per day. So in this one, we want to go ahead and construct, we have our frequency from above. Let's go ahead and double check that. What did we have? We had 353,621. So let's go ahead and write that in here. We have 3, 5, 3, 6. Oops, got a little off there. Hold on. Let's do 3, 5, 3, 6, 2, 1, because we're dealing with the same data set. So the idea now is that we want to come up with the relative frequency for that. So when we look at the relative frequency, remember the sum here is 20. When we look at the relative frequency, we're going to take this number and divide it by this number. Then we're going to take this number and divide it by this number. Remember, it's a fraction or a proportion or decimal of out of that total. So what's the relative frequency? So let's go ahead and erase that so it's not too confusing. And let's go ahead and take a look. So for the first one, for 2, we're going to say 3 divided. I'm just writing it on the side so you guys know what I'm doing. 3 divided by 20. And we're going to write it with 2 decimals, 0.15. And this is our relative frequency. All right, then we're going to do 5 divided by 20. which is 0.25. Now, we don't need to do the math for that 3 divided by 20. We already know that it's 0.15. And then we need to do 6 divided by 20. It's going to give us 0.3. And then 2 divided by 20, which should be 0.1. And 1 divided by 20 is going to give us 0.05. Now, remember in the last one, we said that all the numbers should add up to the same number of data value. So here it was 20. Your relative frequency should always add up to 1. That's because you couldn't have more or less than 1. Remember, we're dividing each of these by this. So the total of it should be 1. So let's just check that real quick. 0.15 plus 0.25 plus 0.15 plus 0.3 plus 0.1 plus 0.05. And I get 1.0. So we're good there. All right, so that's the relative frequency. Okay, when all the previous relative frequencies are added to the current row, this is the cumulative relative frequency. So what we're saying now is that we're not totaling all of them, we're totaling them for each thing. So we're totaling here, let me go through the example. I think this might actually help a little bit. So, all right, so I just quickly filled that table in just to save us a little bit of time in the video. So what I just did is copy the frequency and relative frequency from the last 2 examples we did. So now what we're going to do is look at the cumulative relative frequency. The idea is the first one is just going to be the same, but then you're going to start adding it. So now we're going to add 0.25 to 0.15. So 0.25 plus 0.15 is going to give us 0.4. And then we're going to add 0.15 to 0.25 to 0.15. And that's going to give us 0.55. Then we're going to add 0.3 to all of that, right? So 0.3 plus 0.55 is 0.85. Then we're going to add that 0.1 to all of that, and that's going to give us 0.95. And then the 0.05 we add is going to give us 1. Right here, it's very important to notice your last cumulative frequency value should be 1 for the same reason, that we saw a total of 1 here, right? We're saying here that this makes up 100%, and here we're saying that all of these together is 100%, which makes sense. All right, if you are asked to find the lower and upper limits, subtract the smallest data value from the largest. Take the result and divide by the desired number of classes. So here's an example. A teacher asked students to rate their anxiety level on a scale of 1 to 100. 1 is the lowest and 100 is high, just before taking the ACT. The responses are shown below. Construct a relative frequency table using 5 classes. So what we're saying here when they talk about these upper and lower limits, we're saying, well, how do we make a range of values for each of these frequencies? So in this case, we can't have 1, 2, 3, 100 different values in our frequency table. What we would like to do is have ranges of values, maybe like 1 to 10 or 30 to 20, or excuse me, 20 to 30. So the idea is that how do we come up with those bands or those widths or those ranges for those different classes? So this one is telling us to take the highest number, subtract from that the lowest number, and then divide by the number of classes. Well, a couple of things we read right here help us with that. We know we need 5 classes. So now we just need to find our highest and lowest number. So looking right here, I see lows, it looks like 33 maybe is the lowest, 34, that's the lowest. So then looking through at the highest, I see 70s, 60s, 84 looks like the highest. So what we're going to say then is our upper and lower limits, or the size between them, is going to be 84 minus 33 divided by 5. All right, so when I do that, 84 minus 33, then I get 51 divided by 5. So we know we're going to be kind of close to 10. It's going to give us 10.2. In this case, we have only integers, and 10.2 is not an integer, so we're going to round up to 11. So in that case, even though it's not 10.5 or higher, you still round up in this situation. So we're going to start with our lowest limit, and we're going to add 11 each time. 44, 55, 66, 77. And then, that's a horrible 7. 77, there we go. And so then what we need to do to find the upper limit is we basically add 11 and subtract 1 because we're dealing with just integers here, and it needs to end before the lower limit of the next class. In other words, we're going to say 33 plus 11 minus 1. So 33 plus 11 is 44, minus 1 is 43. Again, that's because it has to be 1 less than the lower limit of the next class, because in this case we are just dealing with integers. So the next one would follow the same pattern. So we can, in here you can either keep adding the 11 minus 1 from the lower limit, or you can just add 11 to the previous upper limit. So in this case we're going to have 54, 66, 65, 76, and then adding 11 to that, we're going to get 87. So those would be our classes. So then in order to find we're going to do the frequency and relative frequency of those. So what we need to do is go back to our numbers. Okay, so for 33 to 43, we have, let's see here. Let's use a blue color just to kind of help us notate it. So for 33 to 43, we have, let's see, any of these, 33 to 43, here with 33 and 34, any low 40s? Hold on. And here we have 39. So there's 3 in that category. Let's look at 44 to 54. 44 to 54. We have 1, 2, 3, 4, 5. So we have 5. And then for 55 to 65, 55 to 65, we 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 here. Now let's look at, we are looking at, let's see, we have 66 to 76. So we have 1, 2, 3. And then for the last one, we have 77 to 87. I believe that's only 1. Let's double check our numbers. Again, we should have 20. So let's see what we had to. If 3 plus 5 is 8, plus 8 is 16, plus 3 is 19, plus 1 is 20. So that means our numbers are likely correct. And now we need to do our relative frequency. So first we're going to do 3 divided by 20, and that's going to give us 0.15. 5 divided by 20 should give us 0.25 because it's 1/4, 0.25. 8 divided by 20 is 0.4, and we already know 3 divided by 20 is 0.15 from that first class, and then 1 divided by 20 is 0.05. And let's just double check. We have 0.15 plus 0.25 plus 0.4 plus 0.15 plus 0.05, and that gives us 1.0. So that's another quick way to go ahead and check your answer. All right. All right, that's enough. Well, I'm going to split this up into 2 different 15-minute sections because that's the recording limit I have. So I'm going to go ahead and cut that for part 1. And I'm going to pick up with part 2 with histograms in the next video.